Today I'm going to solve a problem that's LeetCode 22, generate parentheses. So let me read the question for you. So given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. So let's extract some keywords here. So there will be n pairs. So n should be an integer. And then we need to write a function to generate all combinations. And then another keyword is the well-formed parentheses. Basically, they are all valid parentheses. So if we have an invalid parentheses, that it won't be in our output. So the first things we think of, it is depth first search algorithm, because it's required us to output all combinations. So so let me draw a diagram for you. So in order to generate all parentheses, we need to draw the recursive tree here. So from the beginning, imagine that we have nothing. So in this case, we can add either the left parentheses, the open parentheses, or the closing parentheses. So, and then let's ignore the well-formed format here. So if we use this algorithm, we can have a different answers, a different solution, different possible solution in this layer. Okay, so if we add the pruning into our recursive tree, we can consider this one as invalid. Okay, so before we dive deeper, so we need to think about how many levels we are going to have. Say if we have n pairs, if n equals to 3, which means we have 3 opening parentheses and then 3 closing parentheses. So if we have if the number n equals to 3, which means we will have 6 layers. Each layer, each decision making, we will have left parentheses added and right parentheses added. And then the restriction will be the number of left parentheses should be greater than the number of right at this moment. Then we can add right parentheses. Okay, so another option is that we can add left parentheses if it's less than the total number of left parentheses, which is n. So if we fulfill these two criteria, we are able to achieve our goal. So let's see how the recursion tree will be look like. So this one we will add the first one. This one is level 1, level 2, level 3. Imagine that we will have level 6 here. So each node of the tree, we are going to add right parentheses or left parentheses. So add left and add right. Okay, So it's a little bit abstract here. So let's dive into the code. So we notice that we need to output a list of string. So yeah, let's give them what they want. So we may have some corner cases here. So if the number of n is less than or equal to 0, we are going to give them an empty list. So, so let's construct our helper method. So I don't think we need to return anything in our helper method because it's going to do the DFS traversal, and it will go through every possibilities and until we reach the bottom of the tree, and then we're going to add it to the result. So let's think about what parameters we need. We probably need the integer n, and then we need to know how many left parentheses we added and how many right parentheses we added it in specific level. And also we need to think about how we're going to construct our prefix. So this one will be a string builder called a prefix. And then of course we need our result string to collect all the answers. So our base case here basically it means we reach the bottom of the tree. So if left plus right is equals to 2 times n, that means so all the parentheses are in place, and this one will be a valid form of parentheses. And then we're going to add it to our result. And we can return. So according to our constraint, firstly, we need to add the left parentheses if the number of left parentheses is less than the number we need to add. So we add a right. And then and then we can go to our next level, which means we need to add increment our left parentheses, and then in this case our right parentheses stays the same, and then we put our prefix in. For backtracking, every time we add a new parenthesis, we need to remove it. We need to delete it. Is this a correct API? Delete char at. This is correct. Need to remove the last one. And then for the right parenthesis, if the number of right parentheses is less than the left parenthesis, we can add it up. the same case, we need to remove it. All right. So for in our main function, what are we going to put in our helper function? We need to put the n there, and then we start with 0 left and 0 right. Our string builder needs to be created. And eventually we need to return our result. So let's review the code. So if n equals to 3, and 3 here, base case is correct, then yep, looks good to me. Let's run the test. Error 16. Comma is needed. Stupid mistake. Yep, it looks like we had the right answer. Yep, we beat hundreds. So let's analyze our time complexity here. So so if we draw the tree again, we start from nothing, and then we have 6 level, including the pruning. I think each level we have 2 branches for each node. So, and then we have 2 n levels here. So, and then each level we will have, we have 2 branches. So eventually the big O notation will be 2 to the 2n. To the power of 2n, and then in the very end we have a 2 string, which means we need to times n eventually. For the space complexity, we have we only care about the height of the tree, so which means we will have 2n. And eventually we can have a dominant form of big O notation, which is big O of n. All right, that's the end of this video.